In this video, we're going to talk about how to find maximum and minimum values of a quadratic. So the first question we have here says, state the maximum or minimum values of the following quadratics. So the first one says y equals 2 bracket x minus 4 squared plus 5. So to figure out if it's a maximum or a minimum on the first one, we're just going to draw a little sketch of what we think this looks like. Now we've been practicing transformations. So if I take a look, there are three numbers here. I have the 2, the negative 4, and the plus 5, and I'm going to start with the plus 5. The plus 5 would move my graph up 5. That negative 4 should move my graph to the right 4, and the 2 would be a vertical stretch of 2. Really, that means it's going to be 2 times thinner than a regular parabola. Now, if I wanted to draw a very rough sketch of what this looks like, my graph is going to go to the right 5 and up 4, and that's where we would find the vertex. And then since it has a stretch of 2, it's going to be a little bit thinner, and it's going to be opening up. So if I take a look at this little picture here, does it have a maximum or a minimum? Well, it has a lowest point down here at the vertex, so I would say that this has a minimum. And the minimum value would be a y value, so it has a minimum of 4. Now we go a little further and say it has a minimum of 4 when x equals 5. Just so we know where it is on the graph when it happens. If we take a look at the next one, we have y equals negative 3 times x plus 2 squared plus 10. So I'm going to start by doing the transformations. I'm going to draw a little bit of a sketch, and then I'm going to look to see if it has a maximum or a minimum and what the value might be. So this plus 10 means my graph is moving up 10 from 0, 0. Plus 2, this time that means it's going left 2. Now this minus 3 has two jobs. The minus makes it a reflection, which means it's upside down. And the 3 is a vertical stretch of 3, which means it's going to be 3 times thinner than usual. So if I draw myself a very rough sketch of what that looks like, it's going left 2 and up 10, and then that's where my vertex is. It's a reflection, which means instead of being up, it's going to actually be upside down, and it's going to be thin because of the stretch of 3. So if I take a look at this graph, this one doesn't have a lowest point this time, it actually has a highest point, so this has a maximum. And the maximum value is going to be 10, so it has a highest point of 10, when x equals negative 2. Now, there is a way to do this without graphing. You'll notice that the maximum and minimum value in both cases came from that number that told us whether we went up or down, which in our equation is known as the k. And the 5 and the negative 2, you'll notice, came from inside the bracket, except they're opposite what you see there. So that is normally h. So this appears to be negative h. It has the opposite. And whether it's a maximum or a minimum really depends on whether my graph is right side up or upside down. And what flipped this graph upside down was that negative in front right there that made it a reflection. So to figure out whether it's a maximum or a minimum, you need to look at the sign on your A. To get the maximum or minimum value, you need to look at your k value, that number at the end that's being added or subtracted. And to figure out where your maximum or minimum occurs, we look inside the bracket at our h value. So If our A is positive, it's a minimum. If A is negative, it's a maximum. And I'm just going to make a note that either our max or our min equals our K value when X equals the opposite or negative H. So let's give that a try. We'll do a couple of questions and see how it goes. We've got two more here. It says determine the maximum and minimum values of the following quadratics. And the first one is y equals negative 2x squared plus 6x minus 1. Now the first thing I notice is that this does not look like the ones up here. It is not in what we call vertex form. It's actually in standard form. So to turn it from standard form into vertex form, we need to complete the square. So to complete the square, I'm going to group together all my terms with an x and take out whatever the coefficient of x squared is. So that's going to leave me with x squared minus 3x. And then we want to try to find our magic number. Now we completed the square in yesterday's lesson, and this number always seemed to work out a little bit more nicely. These ones are going to be a little off today. What I want to do is I want to stretch this into a trinomial that I can factor. So what I need to do is find a number that I can put here that will make this factor nicely. So I know that I need it to add to negative 3, and the number that goes here is the number that the numbers are going to multiply to. So I'm looking for two numbers that add to negative 3, and we talked yesterday about how it really needs to be the same two numbers. So I need the same two numbers that are going to add to negative 3, and an easy way to do that is just divide by 2. So I'm going to say negative 1.5 and negative 1.5, and then I'm going to multiply these two together to get positive 2.25. So I'm going to add 2.25, and then we can't just randomly add these numbers into the bracket. I also need to subtract 2.25 and really leave enough space there. All right, on the next step, what we need to do is remove that negative term from the bracket. It's not part of what I want to factor. It's kind of this leftover bit. So what I need to do is I need to multiply it out of the bracket by multiplying it by that negative 2. So I leave the negative 2, I leave the x squared minus 3x plus 2.25, and I'm going to multiply negative 2 out front times negative 2.25. And I end up with positive 4.5. I'm going to add these two together. Get 5.5. And then my last step is to factor what's left here. So I'm going to do that a little bit lower down. I'll leave myself a little bit of space to do some other things. So I'm looking for two numbers that multiply to 2.25 and add to negative 3. Well, it's very convenient that they happen to be negative 1.5 and negative 1.5. I've actually already figured that part out. So I'm going to take x squared minus 3x plus 2.25. Usually I do this in the margin, but I don't really have room in my margin. So I have x squared minus 1.5x minus 1.5x plus 2.25. Group them. Factor out an x out of the first pair and a negative 1.5 out of the second pair. and I am left with x minus 1.5 times x minus 1.5. And since they're exactly the same, that's actually x minus 1.5 squared. So I'm going to replace up here this with x minus 1.5 squared plus 5.5. So I could draw a sketch, but we're interested in max-min today. So I know that since it's negative, it's going to have a maximum. Okay, I know that this, the 5.5, will be the max value. And that this is going to be where it occurs. So therefore, the maximum is 5.5 when x equals not negative 1.5, but positive 1.5. Now let's try, we have one more. So I have y equals 1/2 x squared plus 4x plus 9. Now I do notice that this one has a fraction, and if it's a fraction that works out to be something nice that you don't have to round, I am okay with you making it a decimal, but sometimes it's not so bad to try and work with the fraction. So to complete the square, I'm going to group my 2, and I'm going to take out the 1/2. This is easy, it's an x squared. Now 1/2 times what gives me 4? Now if you're having trouble figuring that out on your calculator, you can do 4 divided by 1/2, and that would work. But 1/2 times 8 is going to give me 4. I need to find the number that's going to make this a nice factorable trinomial. So I'm going to stretch it out into 4 terms, actually 3 terms, but we always end up with that extra piece. I'm going to look for 2 numbers that add to 8. They need to multiply to something. Now we need the numbers to be the same, so 2 numbers that are the same that add to 8 would be 4 and 4. 4 plus 4 is 8. 4 times 4 is 16, which means my magic number here is 16, and we're going to add 16 and then subtract 16 from the bracket, because if I just add 16, it changes the whole question. I don't want the negative. We're going to bounce that out of the bracket by multiplying it by 1/2. So I have 1/2 x squared plus 8x plus 16. 1/2 times 16 is 8, so I get negative 8 there, plus 9. So 1/2 x squared plus 8x plus 16. Negative 8 plus 9, positive 1. And then all I have left to do is to factor the bracket. So we're looking for 2 numbers that multiply to 16 and add to 8. Conveniently, those numbers we've already figured out are going to be 4 and 4. So once again, I'm going to do that down at the bottom where I have a little more room. So x squared plus 8x plus 16. We're going to stretch that out to x squared plus 4x plus 4x plus 16. Out of the first pair, I can take an x, and I'm left with x plus 4. Out of the second pair, I can take a 4, and we're left with x plus 4. So that's going to be x plus 4 times x plus 4, which is x plus 4 squared. So y equals 1/2 times x plus 4 squared plus 1. Now, this time, it's a positive in front, so this is going to be a minimum of 1 when x is the opposite of this, negative 4. So the minimum equals 1 when x equals negative 4.